Hey all, welcome back to my channel Library. In this video, we are going to see how to do a hands-on coding specifically on linear regression project from scratch. If you are learning linear regression for the first time, we have already seen the basics of linear regression important metric. Now, this is going to be the very much important video. Why? Because here we are going to see hands-on coding from scratch, a complete project workflow when it comes to linear regression. Without any delay, let's get started. First important step that you are going to do when it comes to linear regression projects is importing the important libraries. For my dataset that I'm going to work with, I need these libraries: NumPy, Pandas, Matplotlib, Seaborn, linear regression, mean squared error, and R square values, R2 square values. So here, NumPy is for dealing with numerical values, Pandas is for handling the table dataset, Matplotlib and Seaborn is for creating and seeing my visualization charts and seeing my data. Linear regression is going to act as a machine learning model that is going to predict my data. Mean squared error and R square value is for evaluating my model, how well my model is performing on this particular data. The second step is obviously loading my real data set into my project environment. Here, the data set that we are going to use is MPG dataset that is available online in my Seaborn library. So for that, what I have to do is, the first step is I'm creating a variable name data, then I'm giving sns.load dataset because I'm importing the online available dataset, right? That is why the coding is quite different. When I give mpg inside double quotes, it will be importing and using my online available dataset that is there in Seaborn library. If I just want to confirm if my dataset is loaded, I'm just using data.head to see my first 5 rows. So this is how my actual data set looks like. First, these are all the columns: MPG, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and name. This data set actually here miles per gallon data set. It measures how efficient the fuel is for my car. So specifically, if you want to understand in clear way, we can understand in this way. If my car is giving 30 mpg, it can travel 30 miles using 1 gallon of fuel. It is like getting mileage from petrol or diesel. That exactly is miles per gallon when it comes to another country data sets. When it has high mpg, it says that my fuel is more efficient. If it has lower mpg, it definitely says it is consuming more fuel. Why we are specifically choosing this particular data set? If you are a beginner, this is going to be the best one. Why? Because it is best for data visualization, for creating charts and graphs, and it is best suitable for linear regression to understand the relationship between both. Then for correlation analysis, to understand my feature importance to predict the target value, and also used for understanding the relationship in my overall data. So let's consider an example. If you have questions like does heavy car has lower mpg, or you might have question like does more power horsepower means lower mpg. So if you have all these questions, this model could give you all the answers. The next step after loading the data set into my coding environment is cleaning my data set. For that, I need to find it out if my data have any null values or not. Specifically in this data, we are performing linear regression, right? So we not work on all these columns. We are just going to predict one column using one column. So the column that I'm going to use for prediction is horsepower. The column that I'm going to predict is mpg. So for working with that particular columns alone, I'm doing this. I'm giving data is equal to data of open and close square bracket. Then inside that I'm giving open and close square bracket, inside which I'm giving horsepower comma mpg, because these two columns alone take it into consideration. That's what I'm telling my AI. Then I'm giving drop ne. Why? The purpose of giving this is because if you see any null values, if you see any missing values, just drop that particular row or drop that particular value. Then when I give data dot shape, it will be printing by in my data set what are all the number of rows and what is my number of column. In my data set, I just have two columns, horsepower and MPG. Then what is my number of rows? To see that, I can see this. 392 is my number of rows. Followed by data cleaning, the next step is data inspection. The first step in data inspection is seeing my first 5 rows and last 5 rows. So for seeing my first 5 rows, I'll be giving data.head. As I have just chosen the two columns, here only two columns are shown here. See, horsepower and MPG is only printed with my first 5 rows. When I give data.tail, it will be printing my last 5 rows with just two columns, horsepower and MPG. This particular coding, data.describe, it seems like a small one-line coding, but it is such a powerful piece of my linear regression, specifically when it comes to regression-based algorithms. Why? Because this describe is used for understanding my data set. It will be giving my minimum value, maximum value, mean value. It will be giving my count, 25%, 50%, 75%, that standard deviation values. So if I have a numerical data and that I have many columns that has numerical values. To understand all that columns, if I just give data.describe, I can clearly understand what is the minimum maximum value. So I can clearly get an overview of what is happening inside my data. That powerful is this line of coding data.describe. To understand my data first, this is the mandatory step for every data that has numerical columns. Next to that, the important step is visualization. Under visualization, I can use any charts. Here I am using scatter plot. Now observe the coding part here. What I have to do is plot.figure. I need to give plot.figure to create this overall figure. When I give plot.scatter, it is going to create a scatter plot like this with this kind of blue colored scatters. Here I am giving inside open and closing bracket, I am giving data of horsepower and data of MPG because only for these two columns you are going to create a chart. That's what I am telling my Python coding. This plot.x label, plot.y label, it is completely customizable. So here see in this chart, at the x-axis I have horsepower and y-axis I have miles per gallon, right? This is something that I could give just by using plot.x label and plot.y label. And this title, horsepower versus MPG, this is also completely customizable. Just by using plot.title, I can give horsepower versus MPG. And finally, when I give plot.show, this chart will be created and shown to me as similar to this. The next step is creating and training my linear regression model. So, in this particular step, what you will be doing? What you could do possibly. So here in this particular step, what you are actually going to do is you are actually going to build the model. This is the brain part of my whole coding. Here what I'm doing is I'm just choosing my columns that I'm going to use for this particular model. This is my feature or this is my independent variable. This is my target. This is something that I'm going to predict. So inside capital X, I'm putting my independent variable and inside small y, I'm giving my dependent or target variable. Next to that, when I give create model, under create model, when I give model is equal to linear regression, it will be creating my ML model. Next to that, finally I'm giving model.fit, inside which I'm giving x comma y. This is specifically used for training my machine learning model with this given data. So when I see this as output, it says that my machine learning model is being trained and it got trained. Now, it's time for visualizing the best fit line. In the previous video, we have clearly understood what is best fit line, right? If you missed that, make sure you watch that. Only if you understood that, you can understand this one. Here, I am giving predicted MPG is equal to model.predict of x. Here, for this particular part, this data of MPG is actually the actual value that is there on my MPG column. But using this horsepower, my model is going to learn how the values are changing. right? Based on what it learned, I'll be giving new data for horsepower and I'll check what is the MPG value for it, right? So for that, the predicted values need to be stored inside a particular variable. For that, I'm creating a variable called predicted MPG, which is equal to model.predict of x. Under which, when I give plot.figure, this figure will be created. These steps are almost close to what we have seen in this scatter plot. Next to that, I'm giving plot.scatter because I need to create a scatter plot like this with this two columns, x and y. I mean the horsepower and MPG columns. So that's why I've given x comma y inside this dot scatter. Followed by that, when I give dot plot of x comma predicted MPG, this particular data of x will be plotted here. And when I give predicted MPG, this particular value will be called here. Next to that, I'm giving plot dot x label of horsepower. So x label is given as horsepower. For y label, I am giving MPG. So based on whatever I am giving as customizations, this chart will be created. So that title also. So what I'm plotting here, it's actually best fit line, right? That is why I have given the title as best fit line. And finally, when I give plot.show, it will be printed like this. So to understand my data, the formula will be applied inside. So inside that formula, slope and intercept concepts are applied when it comes to linear regression formula. So this is not mandatory. This plotting and seeing this slope values and intercept values are not mandatory. But when you are doing a professional level coding, it is advisable to add this part too. So slope is like how this line is. And intercept is a value that says about the weight, how the values are changing. So for plotting that, the coding that I have to use is slope is equal to model dot coefficient of underscore of 0. Then I need to give a printing statement of slope and need to call the value. For intercept is equal to model dot intercept underscore. So for printing that, I need to give inside print. I'll be giving this particular value here and I'll be giving the printing statement along with that. So the values of slope and intercept will be printed. With this value, we are not going to do anything. What is happening inside that particular linear regression formula that we are just seeing using this formula. Next, this is actually the important part of the coding. Calculating the error and my model's performance. So generally cost function is about a mean squared error. This is not used for evaluation. Instead, RMSE, root mean squared error, is used for evaluation. For calculating the root mean squared error, need the value of mean squared error. Using this, you will be taking a square root and you will be understanding how my model is performing. So for calculating that MSE value, what you will do? MSE is equal to mean squared error of y comma predicted MPG. So actual value versus predicted MPG. Then I'm giving printing statement and printing the value. So this is my MSE value. Before moving to RMSE, we have important step. This step is like if I'm giving any random values for my horsepower, what will be my predicted MPG? For checking that, I'm using gradient descent here. For plotting and seeing that, I'm giving example prediction is equal to, this is completely customizable. I'm giving model.predict of open and close bracket, open square bracket, close square bracket, then open close square bracket, inside which I'm giving a random horsepower value. So here I'm giving 120. Okay, for this I need to predict and print my MPG value. So for that, inside a printing statement, I will be giving my printing statement. Then I'm giving example predictions of 0. So for this, the value will be predicted and printed like this. So for this given 120 horsepower, the predicted MPG is 20.99. So this is one of the optimization algorithm. So if increase the efficiency of my algorithm, I'm using this technique. And now here comes the evaluation metrics. I'm going to evaluate how well my model is performing. So for that, now see here I'm using np.square root, right? Here it is about taking square root of MSE and storing it inside RMSE value. So that is why I'm giving RMSE is equal to np.square root of MSE. Then I give printing statement, I'll be printing this value. Then for R square, the formula is R square, comma, underscore, comma, score, underscore, score. Then I'm giving y, comma, predicted MPG, And finally, I'm giving printing statement. Inside a printing statement, I'm giving a printing statement and I'm calling this value R2. Now, by using this RMSE value, I can check how much error it is making. And R square is for understanding what is my accuracy of the model. And finally, I'm plotting and seeing the residual analysis. So residual analysis is about understanding the difference between actual values and predicted values by creating a plot. So for the first step is inside residuals, I'm giving the formula as y comma y minus predicted MPG. That is actual values in MPG minus predicted MPG. Now followed by that, I'll be giving plot dot figure for creating this figure. That I'm giving plot dot scatter, and I'm using these two values, predicted MPG value and then this residual values for creating this chart. Here I'm giving something new like AX H line, right? This is for creating this line. So my scatters are clearly visible. I can see what is actually happening. Then I'm giving X label, Y label, and finally the title for creating this chart. When I give plot dot show, the chart will be created like this. Now I can clearly see the chart is not giving me clear observations. I could see the data is spread. It is messy. It is not a linear line at all. I can't say it is like a best fit line. It is not straight at all, right? It is not constantly increasing. It's not constantly decreasing. Why? Because in this particular data set of MPG, we do have so many columns, right? I'm trying to predict MPG just with the horsepower. So for predicting the MPG, I need to know the cylinders, displacement, weight, acceleration, everything. Only then the model will perform well. The errors will be very less. Now my model is expecting more data. So this particular data is not enough. But when it comes to this value, R square value and root mean square value, based on this given data with just one column, the value of RMSE is quite good. Even the R square value is quite good because we just used one column, right? So for this one column, if it is giving this accuracy, it is absolutely great one. So now in this video, you clearly learned all these steps. Real data set loading, data cleaning, data inspection, visualization, model training, best fit line, model parameters like slope, intercept, cost function, gradient descent, optimization algorithm, evaluation metrics like RMSE, R square values, and finally the residual analysis. So if you are a beginner, you have already done the important foundation step when it comes to machine learning algorithm. So already 10 to 20% ready for the AI and data science based interview. Still, I would say it is just 20%. Why? Because we do have so many things in the upcoming videos that's very much important for the interviews. So if you do not want to miss any updates, make sure you subscribe my channel so you'll not be missing any updates. Make sure the notification is always kept on so you'll not be missing any videos. So bye for now. We'll meet you in next amazing video. Bye.